Today we're going to be going over how to draw Bohr diagrams in a step-by-step guide. First, we start by looking at the periodic table of the elements. And we notice that the periods are on the left-hand side here, 1, 2, 3, 4, 5, and 6. And the group numbers are above the top here, group 1 through 18. Period numbers indicate the number of shells that the element has, and the group number indicates the number of electrons in the valence shell, or the valence electrons. For our first Bohr diagram, I've selected bromine for us to draw. Bromine is in period 4, therefore it has 4 shells. It's in group 17, therefore it has 7 valence electrons. Similarly, if it were in group 16, it would have 6 valence electrons. Not only do we know the number of shells bromine has and the number of valence electrons, we know based on its atomic number, the number of protons is also 35 and the number of electrons is 35 for bromine. Based on its atomic mass of 79.904, which we can round up to 80, we now know the number of neutrons, since the atomic mass equals the number of protons, 35, plus neutrons. Therefore, 79.904 minus 35 equals 45 neutrons. I'm starting here in the bottom left. So let's regroup. Everything we know about bromine. We know that it's in period 4, therefore it has 4 shells. 1, 2, 3, 4. We know it's in group 17, therefore has 7 valence electrons, right here. We know its atomic number is 35, therefore it has 35 protons, here, and 35 electrons, because protons always equal the number of electrons. The electrons are what we draw here in the shells. The atomic mass is 79.9, which we round to 80. 80 minus 35 protons equals 45 neutrons, which we indicate here. So always in the nucleus are the protons and the neutrons. The way that we fill in the rest of these electrons, since we started with the valence electrons knowing that it's 7, we now jump to the innermost shell. We know that it's 2. It maxes out at 2. So we fill in 2. We know that we're trying to reach a total of 35 electrons. So now so far we're at 7 and 2, which is 9. Then we start to work our way out. The max number of electrons the second shell can have is 8. So we max that out at 8. Now we have a total of 17 electrons. 7 plus 2 plus 8 is 17. This is the only one that would be empty. We simply do 35 minus 17. 18 are left over, so we fill this in with 18. It's important to note that the maximum number of electrons in each shell are indicated here. The valence shell, or the outermost shell here, can only have a max of 8 electrons, no matter what element it is. Let's try another quick example. Phosphorus, here, we know it's in period 3, therefore it has 3 shells. We know it's in group 15, therefore it has 5 valence electrons. Okay, we know phosphorus has 3 shells because it's in the 3rd period. We know that it has 5 valence electrons because it's in group 15, based on its location in the periodic table. And we always know that the first shell has 2 electrons. So this is the information that we can fill in so far. The number of shells, the number of valence electrons, and that there's 2 electrons in the innermost shell. We do not know the number of protons, number of neutrons, or the rest of the electrons. We're going to do that math real quick. So now we must fill in the number of protons and neutrons, fill in the remaining number of electrons. So to do this, we look at phosphorus's atomic number. We know that the atomic number equals the number of protons, that we put here, It equals the number of electrons that we're going to fill in here. We do this with simple math. 5 electrons in the outermost shell plus 2 in the innermost shell plus something equals a total of 15 electrons. Simple math, 5 plus 2 plus 8 electrons that we fill in here equal a total of 15 electrons. Now, to figure out the number of neutrons, we look at the atomic mass, which is here. The atomic mass rounded is 31. We know that the atomic mass equals the number of protons plus the number of neutrons, or 31 minus 15 protons equals the number of neutrons. 31 minus 15 protons equals 16 neutrons that I indicate here. And I have officially drawn the Bohr diagram for phosphorus. Now you can practice drawing Bohr diagrams on your own.